Let's look at expanding double brackets. So when we expand double brackets, we use a method called the FOIL method. It's an acronym which stands for the following. So F is for first, O is for outside, I is for inside, and L is for last. So in this first example, we've got two brackets, which are x plus 1 and x plus 2, and we're going to use the FOIL method to expand these brackets. So we start with the first term, which is x, and we multiply it with the first term inside the second bracket, which is also x. So we're going to do x times x, which equals to x squared. Then we look at the terms on the outside. The terms on the outside are x in the first bracket and 2 in the second bracket. So we do x multiplied by 2, which gives us plus 2x. Now we have the terms on the inside. So the insides of the brackets, the first term in the first bracket is 1. The term in the second bracket is x. So we do 1 times x, which is plus x. And then finally, we multiply the last terms together. So the last term in the first bracket is 1. The last term in the second bracket is 2. So we do 1 multiplied by 2, which gives us 2. Now collecting like terms, we end up with x squared, which can't be added to anything else. And then 2x plus x gives us 3x. And the 2 can't be added to anything else, so we have plus 2 on the end. And so expanding x plus 1 and x plus 2, we end up with x squared plus 3x plus 2. Let's look at this second example. So we have x plus 3 all squared. Now, a common misconception with brackets like this is to think that when we expand this, we get x squared plus 3 squared, which is the same as x squared plus, so 3 times 3 is 9. This is not correct. This is incorrect. What we do instead is we know that x plus 3 is all squared, and so that's the same as writing two separate brackets. So we have x plus 3 in brackets multiplied by x plus 3 in brackets. Now using the FOIL method, again we start with the first term, so that's x, and we multiply it with the first term in the second bracket. So x times x gives us x squared. Then we start with the terms on the outside, so x multiplied by 3, that gives us 3x. Then we look at the terms on the inside, so 3 times x, which is 3x. And then finally, the terms are last, so that's 3 times 3, which gives us 9. And so collecting like terms, we end up with x squared plus, so 3x plus 3x is 6x plus 9. And so notice how this is different to x squared plus 9. This is the correct method. This is the incorrect method. Looking at the next example, we have 2x plus 3 in brackets multiplied by x minus 2 in brackets. So again, using the FOIL method, we start with the first term, so 2x times x, which gives us 2x squared. Then we look at the terms on the outside, so 2x times, this time we've got a negative in front, so we need to include that. So 2x times minus 2, which gives us minus 4x. Then we look at the terms on the inside, so 3 times x, which is 3x. And then we look at the terms that are last, so 3 times minus 2, remember we've got the negative sign, so 3 times minus 2 gives us minus 6. So collecting like terms, we end up with 2x squared minus 4x plus 3x gives us minus x, and then minus 6 on the end. So 2x plus 3 in brackets multiplied by x minus 2 in brackets equals to 2x squared minus x minus 6. Now looking at this example, we have 4 minus x all squared. So again, remember the common misconception is to think that this is the same as 4 squared minus x squared. And so that would be 16 minus x squared. This is not correct. Write this as two separate brackets since we have 4 minus x all squared. So this is the same as 4 minus x in brackets multiplied by 4 minus x in brackets. Now using the FOIL method, start with the first term, so 4 times 4, which gives us 16. Then we have the terms on the outside, so 4 times, remember the negative sign, 4 times minus x, which is minus 4x. Then we look at the terms on the inside, so minus x times 4, which is again minus 4x. And then we look at the last terms. So minus x times minus x, remembering to include the negatives. So minus x times minus x is plus x squared. And so collecting like terms and rewriting this so that the x squared term is first, we have x squared, and then minus 4x is minus 8x, and then plus 16 on the end. And so this is the correct way of expanding 4 minus x all squared. Now more generally, if we have two terms in brackets that are squared, we can use the following to expand very quickly. So a plus b all squared is the same as a squared, so that's the first term, we square it, plus the two terms inside, so a times b multiplied by 2, so 2ab, plus the second term all squared, so that's b squared. So generally, whenever we have two terms inside a bracket and we're squaring, we can use this method. So let's look at this example to verify that this works. So we've got 2x minus 3 all squared. So using our general form, we first need to square the first term, so that's 2x. So 2x times 2x gives us 4x squared. Then we multiply the two terms inside, and we also multiply by 2. Now 2x minus 3 all squared is the same as 2x plus minus 3 all squared. The plus and the minus would simplify to minus here. And so the two terms we have are 2x and minus 3. We need to include the negative when we're expanding. So multiplying the two terms together, 2x times minus 3 gives us minus 6x. And then we also multiply by 2, which gives us minus 12x. And then finally, we square the second term, so minus 3 times minus 3, which is plus 9. This is the quick way of expanding a squared bracket like this. We check this using the FOIL method. So first we need to write this as two separate brackets. So 2x minus 3 in brackets multiplied by 2x minus 3 in brackets. Now we start with the first term, so 2x times 2x, which gives us 4x squared. Then we have the terms on the outside, so 2x times minus 3, which is minus 6x. Then we have the terms on the inside, so minus 3 times 2x, which is minus 6x. And then we have the last terms, so minus 3 times minus 3, which is plus 9. And then if we collect like terms, we end up with 4x squared minus 6x is minus 12x. And then we have plus 9 on the end. And so we see that indeed, this is the same as what we get if we use the quick method, where we use the general form for a squared bracket.